Our last speaker is Camilo Gomez from Yokogawa. He's here to talk to us about the Open Process Automation Forum, which you probably have heard about here at past forums in the last couple of years, and give us a bit of an update from a cybersecurity angle. So, Camilo,
thank you. Thank you. So, as you heard, Eric, I'm here to talk about OPAF, Open Process Automation Forum, and what we're doing there regarding cybersecurity. So, let me start. So in terms of background here, you can see that I'm a co-chair of security subcommittee of OPAF. That's the reason why I'm here. So let's start with what is OPAF, for those of you who are not aware. But OPAF is a standards-based, open, secure, and interoperable process control architecture. So it's a standard to build a process control architecture that is based on standards that who has an ambition to be secure and interoperable. So our standard is based, as I mentioned to you, on reference standards. So we have worked in 2 versions so far. Version 1 was completed in 2018, but the official version was released in 2019. We're working on version 2, and we have a preliminary version that's soon to be released, and the versions, subsequent versions. So what we did in OPC UA, in version 1. So we selected 3 main standards, reference standards, that will provide the functionality that we need for those components in the architecture. So the first one, related to connectivity, of course, is OPC UA. That's the selected standard. It doesn't mean that we're using all the features and functions defined within OPC UA, but selected the ones that are appropriate for the new components in the OPAF environment. Similarly, we chose, and this is an interesting one, we chose an IT, originally IT-oriented standard for management, is Redfish. So system management is being done through Redfish. And again, not all the elements defined in Redfish. We are selecting the ones that are appropriate for the components and platforms we're defining in OPAF. And the last one, of course, is IEC, or ISA-IC 62443, for the elements that are related to component security. Now, I'm going to explain in a minute why component security. This is the key word. Now, for version 2, we are working selecting a new set of standards, as you can see here, that are intended to work more now on that process control architecture. So these are the architectures that just not define functionality, but the process control architecture are required for define those. And from those, we selected, of course, AML, or IEC 627.114, to manage the import-export form. And then we have other standards like IEC 61499 and 61131 that are being used now for as information models, that we're developing information models to use those. Again, the intention is not to use each and every part, but the information models will implement some sort of applications that will help us work with those standards. So if you haven't seen this before, this is the picture on the left is a display of what the OPAS model is. So we have this ecosystem that in which you can see starts in the center with that connectivity framework. And in a way, we have eliminated that history of networks, layers of networks. If they are, but they are behind. We are creating an upper level of connectivity, and that's what we call the connectivity framework. In that environment, you will see in the bottom left a set of new components, physical components, which will have I/O. Some of them will have no I/O, but applications, and some will have now the ones on the right will have connections to those blue elements. The blue element is connection to legacy systems. The importance of this architecture is that it's not only intended to be for the greenfield, but more importantly, it's intended to work in the brownfield. So it needs interfaces to the brownfield and those are done through gateways. The other part you need to have into account in this architecture, of course, is that we are working with not only physical devices, but virtual devices. And why? Because for us, the component is not only the device, but it's also an application. So what the picture on the right is depicting that we are moving away from what we call the device mentality. Here, we are building not only a platform, a hosting platform, and in some cases will be physical, in some other cases will be virtual, but they all will be hosting applications. Those hosting applications are the control applications that asset owners will need to execute in the process control environment. So what is our architecture? Of course, as I mentioned to you, we have two versions. Version 1, the main focus of that one, is interoperability. So we needed to have functions that will allow the systems or components, virtual or physical, to communicate, interoperate. And we wanted to do it, of course, securely. And then we have a new set of the focus for what we call the version 2 is about portability, configuration portability. And I mentioned here layer F applications. You will see the picture on the right shows you that we have that component, central component that we call DCN. That's the host of those applications. There are several layers of applications, but layer F application is that function block, that lateral logic application, that asset owner PID application that needs to be executed in distributed nodes. Then we have layer I, a set of applications in layer F, which are actually related to connectivity, and layer O related to the hosting operating system. The parts in blue are the parts we develop, those interfaces actually, and you see they're mostly external interfaces, nothing internally yet. External interfaces to what we call the connectivity framework, system management, and of course, to some of that infrastructure for connectivity. We're working on the other pieces for version 2. As you can see, we're creating this layer F import-export format model using the AML and the structure, and we're creating the interfaces for that today. So now let's talk about standards. So after I give you this background of what is OPAF, is what was the goal or the mission for us in terms of security? Of course, knowing that is a complex environment, and if you heard me saying the word component, critical components in that environment are physical, virtual, and all the way to the applications. So applications are components in our mindset. And in order to have a secure environment, it was clear for us that we needed to work right from the beginning by defining or ensuring that the components are secure by design. They come out with the right capability, and they are not capabilities that are normally added. Because security until today is an add-on, something external to the component. Now, we want it to be secure by design, comes with the component. Being a standards base, of course, we wanted to find out which is the standard that will give us this reference. And we started with 62443. Now, 62443 is really large, as you can see. They are, well, you have heard today. But we want to concentrate on those, we needed to concentrate on what are the standards that are relevant for component. And from those are 3, and we're selecting 1. So our objective for us, the main objectives, of course, are these architectures ensure the security of the physical platform, the operating system, the communication, and the system management services, and of course, the applications. So how we're going to do that is we have to build that capability in the components right from the beginning. So here, this is a list, not a list, an example of some of the objectives that we need to meet in terms of having an embedded secure component or component with that capability. We need those capabilities. This is not a comprehensive list by any means. It's just a description of some of those capabilities that we need to have in place in order to say that we have a secure component. Of course, 62443 is the standard that we use as a reference, and you know that they have released last year officially both 4-1 and 4-2. 4-2 has been in the cook. It's not something new in a way, but it's new because it's now officially published. And then we have an official standard to meet the security requirements that we want to use for the components. I want to make clear, some people would think that nobody else has implemented embedded security in the components. As Andre could attest to you, for several years, ICS-Security have had what is called an embedded device assurance certification, right? So many vendors have put their components to test. The different thing in the case of us, of OPAS, of course, is since we are trying to have embedded security from the beginning, we wanted to be sure that we not only have the right security capabilities, but capabilities that will allow the functions of our systems to work, starting with interoperability. So we selected one level, security level 2, as the starting point for that. The reason is security level 1 was going to give us a wide variety of options for security, which will not enable interoperability. On the contrary, will be. So security level 2, it narrows those options, and it will help us what we think will build a more interoperable, secure interoperable component. So with that, I finish. I'll say thank you.